friends, welcome to Chindra's smart class. In this session we are going to discuss about multiplicative cipher. In multiplicative cipher we need to perform the encryption operation, multiply the plain text with the key, that is encryption operation, and decryption operation we need to divide the ciphertext with key. So multiplicative cipher, it is monoalphabetic cipher. Monoalphabetic cipher. Okay, here the character in plain text is replaced with another character. Okay, all the occurrences of the same character in the plain text will be replaced by the same character in the ciphertext. That is monoalphabetic cipher. Okay, here in the multiplicative cipher we need to perform two operations: the sender side encryption and the receiver side decryption. Encryption operation means multiply the plain text with the key, and decryption operation divide the ciphertext with key. And all the operations are from Z26 only. Z26 means alphabets, the number of alphabets are 26, so that's why Z26. All the operations, plain text and ciphertext, Z26. So plain text, ciphertext and key also, all those values must be from Z26. So here we need to multiply the plain text with key, and decryption divide the ciphertext with key. So at the encryption side we are going to multiply, and the decryption side, in the place of division we are going to use multiplicative inverse. So we already discussed in the previous sessions multiplicative inverse. For example, if you take 26, okay, so 26 means it is a set of values from 0, 1, 2 and so on 25. Here all the values does not contain the multiplicative inverses, only some values have multiplicative inverse. So what are those values? How can you check whether the value has multiplicative inverse or not, whether the integer? So already we discussed in the previous sessions, you can refer the video. So how can we check? To check whether the integer has multiplicative inverse, we need to use Euclidean algorithm. Using Euclidean algorithm we are going to find GCD. Okay, GCD of n comma a is equal to 1. If GCD of n comma a is equal to 1, that means the integer has multiplicative inverse. So Euclidean algorithm is used to find the GCD. It is used to find only GCD. So using this Euclidean algorithm we can check whether the integer has multiplicative inverse or not. Okay, here n means 26, a means 1, 2, 3 and so on 25. Okay, this is a, and n this is. Okay, and how to find the multiplicative inverse of an integer? To find the multiplicative inverse of an integer, we need to apply extended Euclidean algorithm. We need to find extended Euclidean algorithm. Okay, so here using extended Euclidean algorithm we can find the GCD, okay, and the multiplicative inverse also. So GCD using extended Euclidean algorithm, you can check whether the integer has multiplicative inverse or not, and at the same time we can find the multiplicative inverse also. Okay, so if GCD is 1, that means the integer has multiplicative inverse. Okay, if the GCD is 1, then we can find the multiplicative inverse using extended Euclidean algorithm. If GCD is not 1, then there is no need of finding multiplicative inverse because GCD is not equal to 1. Okay, so this is the basic information. So if you want to know about multiplicative inverse, you must aware of multiplicative inverse. So let's move on to the architecture. So this is multiplicative cipher. Here at the encryption side we need to perform the multiplication operation, and here we need to perform multiplication operation with the inverse. Okay, the inverse of key. Actually it is p divided by k. We are converting division to multiplication. P into k power minus 1. Okay, this is k inverse, multiplicative inverse of k. Okay, so in Z26 we have 12 integers, those contain multiplicative inverses. We have 12 values, those contain multiplicative inverses. That means, what are those values? 1, 3, 5, 7, 9, 11, 15, 17, 19, 21, 23, 25. All these 12 integer values contain multiplicative inverses. So because GCD of 26, 1 is equal to 1 and GCD of 26, 3 is equal to 1. So for all these values, GCD value is 1. All these values are co-prime to 26. All these values are co-prime to 26. If GCD is 1, that means both values are co-prime to each other, relatively prime to each other. Okay, so this set is called Z26 star. This set is called Z26 star. So we need to take key value from only Z26 star. Okay, so from these 12 values only we need to select the k value, because if you select the key, suppose if you select the key 4, then there is no multiplicative inverse for 4 inverse. There is no multiplicative inverse for 4. Okay, so that's why we need to select the key value from this set only. That means Z26 star. So all the values Z26 star, whatever the values in Z26 star, those values contain the multiplicative inverses. Okay, so we need to select the key must from Z26 star, so we can perform the decryption also. If you select the key 4, then we cannot perform the decryption operation. So we cannot get the plain text at the receiver side. Okay, that's why we need to select the key from Z26 star. So this is encryption operation, multiplication, and multiply with inverse of the key, that is decryption operation. Okay, so let us see an example. Suppose if plain text is hello and key is 7. Okay, so we need to select the key from Z26 star 7, which contains the multiplicative inverse. So that's why I have selected the key 7. H E L L O. For H, the integer value is 7. E, the integer value is 4. For L, 11, 11, 14. So how we get these values? We need to assign in numbers for alphabets and so on, A, B, C, D and so on, J. So 0, 1, 2, 3, 4 and so on, 25. Okay, so from this table we will get these values. So 7 into 7 into 7 into 7 into 7 into 7. So 49 mod 26, 28 mod 26, 77 mod 26, 77 mod 26, 98 mod 26. So mod 49 mod 26, 23. This value is 2, and this value 25. This value 25, and this value 20. So for 23, from this table, at 23 we have X, at 2 C, 25 Z, 25 Z, 20 U. Okay, so cipher text is X, C, Z, Z, U. At the receiver side, you need to perform the decryption operation, multiply with 7 inverse. 7 inverse. So 7 inverse means you need to find the inverse of 7. So we already discussed extended Euclidean algorithm, using extended Euclidean algorithm. So this is the extended Euclidean algorithm. Here 26, 7, you need to find the GCD. So GCD is 1. GCD is 1. So that means it has multiplicative inverse. We need to take the value minus 11. Minus 11 plus 26 is equal to, you need to convert the negative value to positive value. So plus 26. Until get the positive value, we need to add n value, that is 26. 15. So 7 inverse is 15. Okay, so here we need to multiply the cipher text character with 15. Each character with 15, we will get the plain text, the receiver side. Okay, so this is about multiplicative cipher. I hope you understood. If you learned something from this video, please like, share and subscribe. Thank you. Thanks for watching.